Hi, my name is Fournier-Viger. It is my pleasure to be there today. Thank you for the invitation for this talk. This talk is called Advanced and Challenges for the Automatic Discovery of Interesting Patterns in Data. In this talk, I want to introduce you to one topic in data mining we call the pattern mining. That means we want to look at some data to find some interesting patterns in the data. Maybe some values appear many times in a database to try to understand the data. So I will give some little overview about this and show you some recent work we did and talk to you also about some challenges related to this. For this talk, I will give some example, maybe about the shopping data, for example, how we analyze the behavior of the customers. But the type of technique I will discuss today can be used also for other things. Okay. So let me move to next slide. Okay. So to give you some overview, introduction about me, I'm professor at the Harbin Institute of Technology in Shenzhen since 5 years ago. Also associate editor-in-chief of the Applied Intelligence Journal. And I do research about data mining, pattern mining, and also some application. So here in this slide, you can see a picture about the map in China. The city of Shenzhen, this is where I am, is located just beside Hong Kong. Okay. So let me give you a brief introduction for our talk today. Nowadays, we have a huge amount of data stored in databases. We talk often about the big data, so the businesses, the government, or other organizations, they have a lot of data in the databases. But even if we have so much data, what can we learn from this data? This is something important. We can use the data to do many things, but what can we truly learn from the data? So there is a need to understand the data. If we want to take, for example, some good decision about the future, or just to understand what happened in the past. So nowadays, a lot of people talk about machine learning, like the deep learning and so on. It works really well for many things, such as image processing or speech recognition. However, sometimes machine learning works more like a black box. So it works really well, but we don't actually know why. So some people, for example, they will use the neural networks and then they will try different architecture to try to find what will work the best. Okay. So there is a need for understanding. If we talk to the business owner, sometimes they want also to understand why we take the model will take some decision. Okay, so today I will talk to you about one field in data mining that is called the pattern mining. The goal is not necessarily to do the very accurate prediction like we could do in machine learning. But the goal is instead to look at the data in very big databases and to find some patterns in the data that will give us some knowledge for the humans that we can understand or interpret. So the valuable knowledge that is interpretable by human, not a black box. So in this field called pattern mining, we design some algorithms to find interesting or useful patterns in the data. And there are many types of patterns we can find in the data, like what is called the item set. It means some set, for example, of products that the people will buy together, some values that appear many times together in the database, or some sequential patterns. This is with the time. A pattern could be you go to the gym, then you go to university, and you go to restaurant. This could be a pattern of location that maybe some user always follow when they are driving around the city, for example. Or it could be other types of pattern. I will talk to you more about this later. So here at the bottom of my slide, I show you one example of pattern we can find in the customer data. Like maybe we find if you buy the cheese or the noodle and other things, then there is 60% probability you will also buy some type of bread. So this is a pattern. It is some values appear maybe many times in the data. Many people buy these products together. And if we find such pattern, it is not like a black box. It is something you can really understand. If you buy this, you will buy this. You are likely to also buy the bread. So why find such pattern? Then maybe some decision makers could use this pattern to take some decision. So maybe we can sell the cheese with the bread together in a store and give some promotion. Okay. So the goal here, we want to find patterns in the data that are interesting. But one question is, in what kind of data can we find the patterns like this that are interesting? So there are many types of data that we can analyze with pattern mining, like the relational database, the graph, the text data, or the spatial data, the sequence or time series, and so on. So in this lecture, I will talk to you in more details about the customer transaction data. We want to look, for example, at what the people will buy on the website, like Amazon or Jingdong and so on. Okay, find some pattern in the buying behavior of the customer to understand them. So this is what we call market basket analysis. It means to analyze what the people will buy in the basket when they go shopping, or online when they go on the online website for shopping. So why we want to analyze the customer behavior? For many reasons, like for the marketing purposes, like if we know the people buy this together, then we can sell them together or do some advertisement and so on. So there are many reasons to look at the transaction data to understand. Okay, so in my presentation today, I will try to give you an overview of what we can find as a pattern in transaction data and a little bit about how it works, okay, but more like an overview. So, what I will consider in this presentation is a type of data we call the transaction database. It is a database where there will be the transaction about what the people buy. So, I will take an example. Let's say that we have a store with some items. That means some products A, B, C, D, E, for example. A is for apple, B for bread, C for cake, D for date, and E for eggs. So we have a transaction database, as you can see in this table at the bottom. And each transaction means some items that have been purchased by some customers. So the first transaction means that a customer has purchased apple, bread, C for cake, D for date, and E for eggs. The second transaction means another customer has bought apple, bread, and eggs, and so on. So we can have the big database like this with many customer transactions. So now if we look at these transactions, we can find that there are some patterns, like many people buy apple and bread together, A and B, okay, as you can see here. So in pattern mining, we will design some algorithms to find what the people will buy together, for example, okay, many times. So if we want to find the useful patterns in such data, they can be it is not so easy because there can be millions of patterns. So for example, you could buy apple with bread, apple with cake, apple with bread and cake, and so on. Okay, there are so many combinations of items that you could buy. So if we want to find something interesting in this kind of data, we need to define what is an interesting pattern. So we need to use some measure to calculate what is an interesting pattern. Okay. So I will show you some example later, but there are many measures like the support. The support means how many times some set of items appear in the database. So for example, with the support, we can find what the people buy the most often in the database. Okay. Other measure we can use, I want to talk to you about today, is the utility. Utility means the importance, like the money. Okay. So instead of finding what the people buy many times, we want to find what makes the most money. Okay. So this is interesting also. Some other measure we can use is the periodicity. It means periodic means something that the people will always buy over time, will always repeat. Okay. So for example, maybe some customer will buy the wine and the cheese every weekend. So this will be a periodic pattern. So what I want to say here is that we have some data. We want to find some patterns in the data, and to select the patterns we want to find, we need to choose the measure. Do we want to find what appear the most often in the data? Then we use the support. Do you want to find what makes the most money? Then we use the utility, and so on. Okay. So in the pattern mining, for this kind of task, there is always only one solution. Okay. So we have some data, we will set some constraint on what we want to find, and some algorithm will find the solution for us, will find all the patterns that will meet this constraint. So this is not a problem or a task where we have many solutions. No, there is always one solution, and we will define some algorithm to quickly find the solution for you, to find the patterns that you want in the data. And this pattern should be interpretable or useful, should help the user to take some decision. Okay. So one of the key challenge in this kind of research topic is how to find these patterns. So as I told you before, there are so many possibilities. You could buy apple with bread, apple with cake, apple with cake and eggs, and so on. So we don't want to look at all the possibilities, but we want to find the interesting patterns in the data. So we will have to use some strategies or design some good algorithm that can look at the big database and find exactly the patterns that you want in the data. Okay. So let me first show you some basic problem about pattern mining to analyze the customer data. Then I will show you some extension, and I will try to give you an overview of some current problem that we try to solve in this field, how to find the patterns in the data. Okay, so the first problem I want to talk to you about is called frequent pattern mining. It was proposed about 30 years ago. So the problem is as follows. We have as input a transaction database, as I showed you before, some database with some transactions about what the people have bought in a store. And then the user need to set a parameter we call the minimum support. It means the minimum frequency. Okay. So, and the result will be what we call the frequent item set. That means all the sets of items that the people buy together and appear at least min-sub times in the database. Okay. So, to make this more clear, let me show you some example. Here I have an example. On the left you can see a transaction database, as I showed you before, okay, with 4 transactions. And if we set the parameter, the minimum support, to 2, that means we want to find everything that the people buy at least twice together, at least 2 times. So the result will look like this. It will be some frequent item set. We find that A appears 4 times. It is a frequent item set because 4 is greater or equal to 2. A and B, apple and bread, is also a frequent item set because A and B appear 3 times together, like A and B, A and B, and A and B. Okay, so 3 times. So, given the database, the parameter, our goal is to find what the people buy many times together. Okay, to find the shopping, to understand the shopping behavior. Now, let's continue about this. So, how can we solve this problem? So, the naive approach or simple approach will be to scan the database, to read the database, to count how many times each possible item set, that means set of item, okay, how many times each set of item appears. So we'll look at A, AB, AC, AD, AE, ABC, ABD, and so on, okay. So if there are n items in the database, then there will be 2 to the power of n minus 1 possible item set. So in my example, it is not so big, okay? But let's say that you have 500 items in a store, then this will be the number of possibilities. So it is not efficient if we look at all the possibilities. We need to use some better algorithms to find the patterns we want in the data. So how does it work? Here I just want to explain to you the key idea about how to solve this problem efficiently. Okay, I will not explain all the details. I want to give you only some overview. So there is a very important property if we want to solve this problem efficiently. It is called the a priori property. It says that if you have some sets of item x and y, and x is a subset of y, then the support of y will be less than or equal to the support of x. Okay. So let me explain this again to make this more clear. It means that if we have two sets of item x that is a subset of y cannot appear more often than x in the database. So for example, please look at the example below. A and B together appear 3 times in the database. It means that if we have the superset of AB, like ABC or ABD or ABCD, any superset of AB cannot appear more than 3 times. So this actually makes sense, okay? If only 3 persons have bought A and B, it is impossible that more than 3 persons will buy ABC, for example, because AB appear only 3 times. But this is a very powerful property that we can use to reduce the search, to not look at all the possibilities and find the solution to our problem. Okay, so frequent item set mining is really useful. It has many applications besides shopping, because although I talk to you about shopping today, you can apply this to many other things. Actually, what I call a transaction is just a set of symbols. So you could apply this to text or many other types of data. So although it is useful, there are some limitations. One of them is that many frequent patterns are uninteresting. So for example, maybe we find that many people buy bread and milk, but bread and milk are some very common products in a store, and even if we sell them many times, they don't generate a lot of money, okay, a lot of benefit. Another problem about frequent pattern mining is that it considers that all the items have some binary quantities. That means you must buy 1 bread or 0 bread. But we don't know if you buy 5 bread or 10 breads, okay? So, but in the real life, if you buy 1 bread, 2 bread or 5 bread, it is not the same thing. And another limitation is that all items are considered as equally important. That means if you sell 1 bread or you sell 1 diamond, it is considered as the same. But of course, if you sell 1 diamond, it makes more money than if you sell 1 bread, right? Okay. So these are some limitations. So in recent years, a new topic has been proposed. It's called high utility item set mining. It can be viewed as an extension of frequent item set mining. The goal is to find the high utility item set, the sets of items that people buy together that have a high utility. Here, utility means the money that will make a lot of money for the business. So in that problem, we have the quantities, like a customer can buy 3 bottles of milks or 4 bottles of milks and so on. And also we have the unit profit. We know if you buy 1 bottle of milk, it will make a $1 profit and so on. So the goal will be to find the patterns that will make a lot of money. So, for example, maybe we can find the pattern like caviar and wine that appear not so often in the data but make a lot of money. Okay, so these patterns we cannot find in frequent pattern mining. So here I want to show you what is the input and output of this problem to give you some overview. Okay, so the input is similar to what I have shown you before. It is a transaction database. So here we have the transactions made by some customers. But not only we know what they buy, but we also have the quantities. So the first transaction is 1A, that means 1 apple, 5B, 5 bread, 1C, 1 cake, and so on. And then we have another table you can see on the right that tells how much money for each apple, for each bread, for each cake, and so on. So A is $5. That means 1 apple is $5. And then the user needs to set a parameter we call the minimum utility, min util. Okay, that means some minimum amount of money. And the goal is to find all the sets of items that the people buy together that make more than or at least this amount of money. So let me show you the example of result. So if we set the minimum utility to $33, the result will be like this. Okay, so these are the sets of items that make at least $33 in the database that I show you on the top. So for example, it means that bread, cake, and dates, B, C, D, make $34 in this database. So it is a high utility item set. Okay, so how to solve this problem? It is not so easy, okay? But before I explain a little bit more about this, I want to explain to you how we calculate the money, because I have not told you about this yet. So how to calculate the money in this problem? So if we want to calculate the utility of BDE, we need to look at all the transactions that contain B, D, and E together. So here we have transaction 1 and transaction 2 that contains B, D, and E together. So let's look at the first transaction. We have 5B, 5 bread. Bread is $2, so 5 multiplied by 2. 3 dates. Dates, D, is $2, so 3 multiplied by 2. And then 1 egg for $3, as you can see here. And then we do the same for transaction 2, and we find that the total is $36. So this is how we calculate the money. So now, why this problem is difficult and interesting for research? It is because the utility measure is not monotonic or anti-monotonic. Okay. So what does it mean? Okay. It means that we don't have the a priori property that I have shown to you before. So in simple words, what does it mean? It means that if you have a set of items like BDE, you could have the superset of BDE that will make more money than BDE or less money than BDE. So it is not like the support, what I explained to you before. So here, for example, if you look at the database, BDE together make $36, but the superset BCDE makes more, $40, and the superset of this, like ABCDEF, make $30 less money. Okay, so why is it like that? So there are some reasons for this. So if you buy more things, like you buy BCDE, maybe it will make some more money because you buy more things together. It should be more expensive. But sometime, if you buy more things, it will make less money. Like ABCDEF make $30. The reason is that if you buy more things together, maybe less people will buy all these things together. So this will decrease the money. So this makes it difficult to solve this problem, because if we have BDE make $36, we don't know if the superset will make more or less money. So maybe we need to look at all the possibilities. Okay, so how to solve the problem? Here I don't want to go into a lot of details because I want to give you some overview about some problem in this field. Okay, but there are many algorithms to solve this problem. Some of them here in green are designed by my team. The key idea about how to solve the problem will be to use some upper bound on the utility of an item set that will respect the a priori property. So we will find some upper bound that will always decrease for the superset of some item set, and this will allow us to not look at all the possibilities. Okay, so here I don't want to go too much in the details about the algorithm because I want to give you some overview, as I said before. I will talk to you now about some other extension of this problem that have been proposed in recent years, especially by my team. So all of this is useful about the high utility item set, but one problem is that we don't consider the time dimension. But as you know, the behavior of customers can change over time. So maybe the people don't always buy the same products. And also, there can be some other regularities, like maybe some people do something periodically, like every week they buy something, and so on. Okay, so I will show you some other problems now that have been proposed about high utility mining to consider the time or other information to find maybe some more interesting patterns in the data. So one topic that we studied in recent work is to find the recent high utility item set. So here the goal is to find what made the most money in recent days or weeks. So for example, for some products you can draw a chart like this. We have the time and the utility, the money, and you can see that maybe some products will make more or less utility over time. So here we want to find the set of products that the people will buy that recently make a lot of money, but maybe not in the past. Okay. So to do this, we use some decay function and we put more importance to what happened recently instead of a long time ago. Okay, so I will not talk into more details about this one. It is just to talk to you about some problems. Okay. Another topic we study in recent years is about finding the concept drift. So here we have a stream of customer transactions. That means we have the data about what the people buy that always arrive over time. And we want to find the drift. The drift, what does it mean, a concept drift or drift? It means we want to find the point in time where there will be a big change in the amount of money that some products will make over time. So here I show you a picture. We have again the time and the utility, and we see that here there's a drift. Suddenly the people will start to buy some products a lot, and it will make a lot of money. So we have defined some algorithm to find such patterns in the data. So how we do this? We use a sliding window that we move over time, and then we do some statistical tests to compare two windows. And if in one window it is significantly different from the other window, then we say there is a drift, and we report this to the user so that the user can take some decision maybe. Okay, so let me talk to you about another problem. It is with the time. It is to find the peak high utility item set. That means we look at the sales of products over time, and we want to find the sets of items that people buy together and make a lot of money, but not always, during some specific time. So automatically we want to find the time where some sets of items make a lot of money. We call this the peak high utility item set. So here I give you a simple example. We have the utility and the time for some products like the moon cake. And in China, we see that these products like the moon cake will make a lot of money, but usually only during some special time of the year, like the Mid-Autumn Festival, for example. So we designed some algorithm for this. Here again, I will not show the details because I just want to give some overview. There are also other problems we can study. So another is to find the trends in the data. So here we have the time and the utility. Here we have some real data, and we want to find when there's some increasing trend. So the time interval where the money will be increasing over time or decreasing, for example. Okay, so this was another topic. Another topic that is interesting is the periodic high utility item set that we also studied in previous work. So the idea is we want to find something that the people will always buy over time, but that will always repeat. So for example, every week some people buy apple and bread, like A and B. So here I show you some example. The input is a sequence of event over time. So we have the timestamp, T1, T2, T3, and so on. And we have what some person has bought. So apple bread, apple bread, A, B, C, B, and so on. So if you look carefully at this data, you will see that A and B always repeat over time. Okay. Every at least maybe 5 transactions, the apple and bread A and B will be bought again by the customer. So we call this the periodic high utility item set. So they also make a lot of money. And if we find these patterns, it can be interesting, because if we know you buy something every week, for example, we could send the message on your cell phone to tell you you should buy again. Maybe we give you a discount, okay, to try to increase the sale of these products. So that was another topic, and I want to show you one more, okay. Another topic about high utility item set is what we call the cross-level high utility item set. So we want to find what the people buy, make a lot of money, but also we want to look at the taxonomy, okay. What is a taxonomy? It means the categories of items. So in the real life, the items in a store will be into some categories. Like computer and cell phone will be in the category of electronic products. Like basketball or a ball will be in sport products. So you can have a taxonomy, and then we can find the patterns that will contain the categories from this taxonomy. Okay. So here I will skip the details because I see we don't have so much time. But my main goal was to talk to you about the problem of finding patterns in transaction. And although there have been many papers about finding the frequent patterns or the high utility pattern that make a lot of money, there are still many opportunities to do the research on this topic actually. Here I want to give you some overview of the current challenge in this field. So some of the main challenge in the field of pattern mining for the research are to design the more efficient algorithm, because it is not so easy problem, and especially if we want to handle the big database, like we need to design algorithm for the big data platform, or maybe for the GPU, or multi-thread, and so on. Okay. Also, we need to design the better algorithm, data structure, strategies, and so on. And also, we need to handle the more complex data with time, and to find and taxonomy, and so on. And we need also to find the more complex patterns that will be maybe more meaningful for the users. We can also design the new measure to select the patterns and find some new applications. So I want to tell you, I'm the author, the founder of popular software to find patterns in the data. It's called SPMF. You can find easily if you search on the web. It offers more than 180 algorithms to find all kinds of patterns in the data, like the binary table, the transactions, the sequence, the graph, many types of data. It is free, open source, and you have the data sets. If you want to do research or use them for some application, it is very convenient. Okay, so this is some picture of the software. It is really easy to use. You can click, choose algorithm, use the data as a text file, and see the results about the pattern you want. The software has been used in many applications, like chemistry, text analysis, shopping behavior analysis, and many other things. Also, I wanted to mention briefly that I'm the editor of a book about high utility mining, and we have also some other book coming about periodic pattern mining and so on. And also, in recent year, we have a workshop on utility pattern mining at the ICDM and KDD conference every year. And we also organize a special journal issue and other things. It is an active research community. Okay, so that was my presentation. My goal was to introduce you about the topic of pattern mining, try to show you some recent research work, and also I wanted to highlight that in pattern mining we try to find the interpretable patterns. Compare maybe to other methods like machine learning, we try to focus more on interpretability. So pattern mining is not really about accuracy, but it is more about finding patterns that are interpretable. So I think in this way it is complementary to the research on machine learning. So that's all for my talk. Please, if you have any question, you can ask me, or you can also send me email. Have a look at my website. There's a lot of resources. Thank you very much.